We're going to continue our discussion of trigonometric functions of any angles, and we're going to talk about using reference angles to evaluate trigonometric functions for angles that are beyond or greater than 90 degrees. So we're going to start with just defining a reference angle. And so it says, let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So if you have an angle that ends in the first quadrant, so we could rotate maybe around once and around again, but that reference angle is that acute angle that you make with the x-axis. In this case, suppose your angle falls in the second quadrant. You drop a perpendicular. Theta star is that acute angle that is formed between the x-axis and your terminal side of your angle. If your angle falls in the third quadrant, you can see here, you drop a perpendicular. Theta prime, or your reference angle, is that acute angle made with your terminal side and the x-axis. And if you have a fourth quadrant angle, theta star or theta prime is that acute angle made when you drop a perpendicular to the x-axis. Now you can use formulas for this, but it really is best to just use logic. So let's start with an example. I've got an angle of 300 degrees and I'm going to draw in standard position. So 300 degrees lands me in the fourth quadrant. I know that if I went all the way around, that would be 360 degrees. I'm at 300 degrees. I want to find out this little angle right here, theta star, that acute angle. That must be equal to, so theta star must be equal to 360 degrees minus 300 degrees, which would equal 60 degrees. Now let's look at negative theta equals negative 135 degrees. I'm going to draw this angle. Negative 135 is definitely short of 180, or negative 180. And I'm looking for this little angle in here that is made when I drop a perpendicular. And so you could either think about how many more degrees would you have to go to get to negative 180 if you were rotating clockwise 135 degrees, and in which case theta prime would equal 45 degrees. If you find that confusing, what you can do is find a coterminal angle and find its reference angle, because an angle and its coterminal angle will have the same exact reference angle. So to find a coterminal angle, I just add 360 degrees to the given angle. So generally when you have a negative angle, you might want to add 360 to give us 225. And now let me draw 225 degrees in standard position. So you can see that 225 degrees is going to land you in the same spot as negative 135, but you just may understand the math a little better. This is 180 degrees, and down here this is 225 degrees. This little angle in here must be 225 minus 180 degrees, which gives you 45 degrees. So the reference angle is that acute angle that you make with the x-axis. So what I'd like you to do is pause the video and try practice problem 1 here, A and B. So I've drawn 390 degrees in standard position. I want to find the little acute angle theta star that is made with the terminal side and the x-axis. If I go all the way around once, that's 360 degrees. So my reference angle at theta prime is equal to 390 degrees minus 360, which would be 30 degrees. With the negative angles, I really think it might be easy for you to first just find an angle that's a coterminal that's between 0 and 360. So I'm going to add 360 to find a coterminal angle. 360 plus a negative 135 is 225 degrees. So when we find the reference angle for 225, it will be the same exact reference angle as we would get for negative 235. So let's draw 225. excuse me, that should be 125. So if I want to draw 125, I know that's beyond 90, but it doesn't hit 180. So this would be the 125-degree angle right here. If I want to find theta star or theta prime, my acute angle, I would just take the 180 and subtract the 125 to find that little piece right there. So 180 minus 125 would be equal to 55 degrees. So your reference angle for negative 235, which is the same as the reference angle for 125, would be 55 degrees. Alright, now let's look at finding reference angles when the angles are in radians. And actually, I think this is even a little bit easier. So let's start with the first one. Find the reference angle for the following angles. I've got 5 pi over 6. I want to draw the angle. And so when I'm drawing angles that are written in fraction form, in radians, I use the denominator to help me out. I know that pi is right here. Pi degrees, or pi radians is right here. So instead of writing pi, I'm going to write 6 pi over 6. That way I can figure out on which side of pi my angle is going to be. Am I going to be in the second quadrant or the third quadrant? And since this is 6 pi over 6, I'm going to be short a pi over 6. So this angle right here would be 5 pi over 6. So my reference angle, the little acute angle that I make with the x-axis, is just going to be the difference between these two. The reference angle is going to be pi over 6. Let's look at 7 pi over 4. We're going to do the same thing. We're going to draw the angle. But this time when I draw the angle, since the denominator is 4, I'm going to call pi would be the same as 4 pi over 4, and 2 pi would be 8 pi over 4. And so I can see now that if I want to draw 7 pi over 4, I'd be 1 pi over 4 short of 8 pi over 4. So if I drew my angle, this would be 7 pi over 4. And theta star, theta prime, my reference angle, is going to be this little angle in here. And so I'm 1 pi over 4 short of 8 pi over 4, so the reference angle is going to be pi over 4. Right, try the practice problem. You pause the video and then turn the video on after you've tried it to check your work. Right, we want to find the reference angle for 2 pi over 3. I'm going to draw the angle 2 pi over 3 using pi as 3 pi over 3. And 2 pi would be the equivalent of 6 pi over 3. And this can kind of help me figure out where this angle is going to go. So I know I'm going to be short of 3 pi over 3, or short of pi. This is going to bring me into the second quadrant. So this angle would be my 2 pi over 3. If I went all the way to pi, that would be 3 pi over 3. And so my reference angle, theta prime, is going to be this little angle in here, this acute angle. And so the reference angle would be just pi over 3, 1 pi over 3. So for 13 pi over 6, I'm going to break up the circle, and this time for pi I'm going to rewrite it as 6 pi over 6 because of the denominator of 6, and I would make this 12 pi over 6, which is equal to 2 pi. This helps us set up where this angle is going to fall. So I know if I go all the way around one rotation, I'm at 12 pi over 6. I need to go 13 pi over 6, which is just one more pi over 6. This is 13 pi over 6. And so theta star is going to be this little acute angle in here, and theta star is just going to be 1 pi over 6.